Hello.
Hi. You joined last time and you're joining again. This is awesome. It's good to have you
Yeah,
here.
yeah. Thank you, thank you.
Bravo. It's really good to see you. Let's see if we're going to get some other folks. Let me check with Mike. And
I went ahead and started recording, Greg.
sweet. I'm just pinging some other folks. We have a lot to get through. So I just want to get everyone there. And then let's see, and Joe.
Are you going to comment on the parity multi-sig wallet breach?
I've only glanced at it. I'm pretty sure we would have caught it with behavioral types, but I don't want to make that claim until I've done the calculations. But just first glance, it looks like the code wouldn't have compiled in Rolang. But let me check that right before I make any claims.
Well, even just using Rolang, wouldn't calling init twice have been preventive?
Well, I mean, it should be okay to call things twice unless it violates a behavioral contract. So that's kind of the issue. I mean, it really depends upon the intended semantics of init, right? We want to provide.
I guess what I'm thinking is, I mean, just in terms of the state of the contract, there would be no way of getting back to init.
It really depends. Again, I have to do some calculations. I just don't know enough to be able to say yay or nay on that analysis. But I understand what you're going for. And
the other thing is the privacy. You wouldn't have exposed init beyond the scope where it was relevant.
Oh, for sure. That's correct. That's absolutely correct. In fact, Kent and Alex Bolkin and Joe and I all had a sort of long conversation about exactly that and how that works. And that's kind of one of the things I really want to focus on today is the methodology by which all of this is being developed. And we can go through this in some detail because Mike and Joe and I are doing a similar thing that we did for the scope of methods, method names effectively. We're doing the same thing for collections right now. And all of these dovetail into pretty much one kind of thing. So we'll be going through that in a lot more detail for the propeller heads.
I know a lot of people, get excited about RChain based on the demonstration that you could have prevented the DAO.
Yep.
Problem. And this exploit was $31 million. It's
no, I absolutely agree. I will publish a paper with an analysis of whether or not the parity bug would have been prevented in Rolang. But I haven't had the time because I'm busy trying to build, RChain. But for sure we'll go and do an analysis. It's on my plate. It's not we're trying to ignore it. It's just I've spoken at length about this. I mean, let me put my camera on and emphasize this. I've spoken at length about this, and everything that I've said 2 years ago is coming to pass. Every single thing that I said, in terms of the scalability in terms of throughput and robustness, and now in terms of the scalability with respect to correctness. Both sides of this, I predicted this over 2 years ago. I said, this is what's going to happen. And lo and behold, every single one of these things has come to pass. And the things that we're doing have a direct relationship to fixing those kinds of behaviors and making a properly scalable blockchain. So, I mean, again, I'm very, very impressed by the will of the Ethereum community and the social response, which is so awesome, right? The social response of the white hats was remarkable, just fantastic, and it really warms my heart because it's, people are really trying to do the right thing, and there's a clear demonstration of that. So I'm really happy about that sort of thing. But there are things that we can be doing to prevent this. Just yesterday, I had a call where with some folks who were doing some due diligence on RChain, and they were asking, so what do you think about this kind of this web methodology of deploy early, right? And how does that relate to deploy the kind of sort of mission critical mode where you test for 2 or 3 years before you deploy anything. And what I've tried to say is that there's a richer methodology that we're going to have to embrace. First of all, we have to recognize that formal methods have come a great deal farther, and if we embed them in our practice of software development in a particular way, then just by compiling your code, you're going to get a lot of these bugs just eliminated. And the second point is that we have to think about nested scopes of risk. So the intuition about deploying early is exactly spot on, because it's not until you test things in the wild that certain kinds of conditions will arrange themselves to reveal lacunae and oversights in one's thinking about the problem, right? So no matter, you could have the spec and the code exactly right, except that the problem that you were solving is different. The problem that you solved is different than the one that you needed to solve. And you only discover that in the wild. And so we have to think about these nested scopes of risk where you can deploy it in a smaller and smaller, an increasingly widening scope of risk. So, for example, if we could deploy in a namespace that was known to be either risky or just a test namespace, and people go and bang the hell out of it. And they are financially incentivized to do so. Then we can have our cake and eat it too, in the sense that it's deployed early and often, but it's in a namespace where it's encapsulated. And the risk is well understood. And then once it passes muster in that namespace, you pass it on to a wider namespace. And once it passes muster in that namespace, then you pass it on to general deployment. And I think that that's kind of the structure that we've been laying the groundwork for. So Jeff, yes. The idea is that we use namespaces as stages, and the reason that's the intent of namespaces has always been to capture what was right and real about service level agreements. So the service level agreements maybe are not considered, the right solution du jour, but there was something true about them, which was within a particular scope, under a certain set of things that you could rely on, then certain outcomes would be guaranteed. So namespaces provide this kind of rely guarantee formulation, which, by the way, Mike Stay and Sophia Tosapoulou and I formalized in a paper in which we interpreted object capabilities in terms of namespaces and other kinds of things that you find in the RChain formalism. But the point is that this kind of rely guarantee approach is facilitated by namespaces and namespaces as staging. So we've that's the sense in which we feel that the RChain framework provides a different kind of development methodology that marries or weds the web methodology of deploy early, deploy often, with something that's much more about mission critical and robust. So we can have both approaches. Yeah, exactly, Joe. So we have a bunch of other things to get through today. Thanks, Jem, for bringing that up. We have done a major reconciliation of the books at this point, so I think Lisa should be able to talk about the status of that. And we're preparing those for general viewing at the members' meeting in October. So we want to make sure that the operations of the co-op are open, transparent, and so all of that information is under construction so that people can stay on track with every single transaction that you see on the blockchain corresponds to these spends with respect to developing towards our goals. Very, very excited to be working with Lisa. It's great to get this stuff done. Additionally, Lisa has prepared a draft spreadsheet so people can get a sense of where we are. Let's see. We have a staffing plan with respect to the co-op spend. Sorry. I'll make that available. Let's see, where is it? Yeah, here we go. I'll do just a screen share right now, and then I'll make the link available after we clean it up a little bit. So hang on a second. And then we are absolutely fully, we really, really want feedback on the staffing plan for people to see how we intend to spend. But essentially, here's the data that feeds into a use of proceeds for any investors that are considering participating in the private sale that's upcoming, or for people who want to engage in the ICO that happens at the drop of Mercury. So I really will be looking forward to feedback here. Please be brutally honest, with respect to numbers or personnel or staffing, anything like that. Let's see if I can get the view. Just it looks like does the view? Yeah. So you can see roughly what it breaks down to in terms of the overall structure of the co-op's development effort. Is there are more or less 5 basic areas. So there's the whole language development, compiler design, etc. There's the consensus elements, the development of Casper and things around Casper. There's the storage capability, and there's the communications capability. And we have roughly 5 developers per group, where most of those developers are working on the feature sets. And then we have embedded developers who are looking at the overall picture, and in particular, they're looking at both testing and DevOps. So 1.5 of those 5 are focused on those kinds of areas, whereas the other 3.5 are looking largely to the feature sets. So this way, each group is focused, on how their features fit into the overall deployment and testing and maintenance. And then that rolls up into the larger effort. In addition, we have some management overhead, which we're trying to keep relatively low, documentation, which is really important. A lot of these things, both testing and documentation, we want to outsource as much as possible via bounties to the community, because that's how education happens, and that's how people disseminate the ideas here. So again, and then there are some other kinds of roles. Like, for example, there's marketing. With respect to marketing, the other thing I want to mention, I just put a kind of a point in the stream here to come back to is how the marketing relates to the release plan. So that's something I'll come back to in a second. So I'm particularly happy with how this is shaping up. And a lot of this information will be in a package, initially packaged as a set of documents for those people who are participating in the private sale. And then will also be made more publicly available as well. Let's see, moving on, and let me stop there actually and just check and see if there are any questions about anything that I've said so far. I tend to just ramble on.
Well, so you're saying that document will be available to the community or people directly investing?
It will be available both to the community and rolled up into some other documents for people who are trying to do due diligence with respect to the private sale.
Got it. All right.
Cool. We also, Alex Bulkin has delivered a draft of the first article in a series for a series of Medium articles that are related to his due diligence on RChain, which is also rolling up into information for investors in the private sale and investors in the ICO that happens with the Mercury drop. Both Ed and I have read the article at least once or twice, and we're quite happy with the article. I think it's very well written, it's very clear, and I'm looking forward to seeing it published. Let's see some other things. The white paper is coming along, but I don't have a draft that I'm ready to release. I apologize. I'm working as diligently as possible. Ed's put in some comments on the sections that are more or less complete, and I've gone through and incorporated those, and I am expanding each section as rapidly as I can. A lot of these are called from talks that I've given, so it's not like it's all of it is fresh material, but it just takes a lot of time to get it all down. So that's where that is. I will be getting a draft out as soon as I possibly can. Let's see. We also have a lot of updates on the technical front. I want to do a kind of deep dive on the methodology that's informing a lot of the technical work, at least with respect to the language and implementation of that. So we'll save that for the end. I want to turn attention a little bit to marketing. For purposes of discussion, I'm not holding the co-op's feet to the fire just yet, but for purposes of discussion, let us say that Mercury drops in July of 2018. It might be considerably sooner than that. It might be a little further off than that, but let's say roughly that's a target. Then we need to begin now with crafting of draft plans for marketing on that drop. And we need to start the community outreach at about the February 2018 mark to get the word out in time so that the ICO. So between here and February, we need to have a draft of a series of messages that go out, and in terms of what the features are, what the functions are, what people can expect in terms of the behavior. And then we need to start executing on that marketing plan beginning in February, so that by the time we launch, everyone knows what it is that they would be getting if they joined RChain. I'm totally looking to the marketing team to help with that, to sort of begin with that process of drafting the message. One of the things that I really want to emphasize is that there will be messages post that. So in particular, it should be right after the ICO for RChain, in which revs are available. That we drop our developer tool story. So we're actively working right now on the developer tools story and how that all fits together. And then right after that, we should be coming out with the first application and how that's sitting on top of RChain. And then right after that, news about the next application. So all of these things now need to be underway in terms of the planning for the message, as well as the actual work on delivering each of those. So again, I'm talking to my marketing team and I'm talking to the community here. We need that. We need to start planning for that at this point. So let me again stop and check in and see if there's any questions or comments about this.
That's all great timing. I know that Lawrence has initiated a meeting with myself, Ed, and Nathan starting Fridays at 7:30 a.m. Pacific and 10:30 Eastern to get clarifying and get going. So that's super exciting, and I'm looking forward to drafting and messaging coming very soon.
Very good. Very good. That's awesome. So why don't I then see if Ed wants to give any updates, and then we'll cycle back to some of the technical discussion.
Yeah, sure thing. Just elaborating a bit more on the marketing side. Lawrence and I spent an hour together working through the list of things we need to do. So in preparation for that meeting, is the first meeting this Friday morning, Patrick?
Yes. Yeah, it should be this Friday.
Okay, great. From the holdings front, we've done a fair bit of backlog grooming and additional work there. Navneet and I are going to be working on that this afternoon, focusing on wallets and wallet features. The Lively Gig team is preparing to work on the wallet UI, and we'll first be integrating with Ethereum, not for deployment purposes, but because there's a back end there, and we want to understand that model and how to get the developers up to speed on it. So that'll be exciting. Wanted to mention also a few great conversations we've had and are planning. Albert's on the call, right? AB7 on Slack. So he and I met last week and talked about his startup, which is review my work and review my music. So they are one of several startups in the music business and blockchain, as is Resonate. Greg talked to Peter Harris in Berlin, and I talked to Peter at the Consensus Conference at end of May. So we have further conversations coming ahead, especially with Resonate in the near future, and so we'll be doing more and more of these kinds of conversations with potential, incubator or joint venture companies that will work with holding. And so we're going to warm up these conversations. Let's see, this coming Monday, there's a presentation. Greg and I will be leading on RChain. This is the third event we've had at the law firm Perkins Coie as our host here in Seattle. I'm not sure that's going to be streaming live, but we'll get it recorded and made available. And Yeah, so it's we invite primarily the Ethereum group in the Seattle area because they're I think the most innovative of the various blockchain groups in Seattle, and we're also inviting a number of potential investors, or at least a few that I've met in the area. So that's cool. Made some updates to the architecture document. Over the weekend primarily. Is interesting. I hadn't read it for a while. The probably the biggest mistake in it was how we originally were describing tokens. As originally phlogiston was described as a token, but really phlogiston is a calculation for the resources. So I think that I was surprised earlier that there was a misperception that I realized is probably coming from the architecture document that was incorrect, and then also clarified the wording around the economic token and just called it a staking token as opposed to an application token similar to ERC20. So I clarified the languages there. Hey, Greg, while we're talking about the architecture document, you mentioned earlier this notion of namespaces and having the consensus protocols roll up. One of the areas in the architecture, and we can cue this conversation up for later if it's involved, but one thing that I was not very clear about, both during our work breakdown structure conversation as well as in the architecture document, is how namespaces will compose, and specifically for the Rev token, how will, on one hand, we'll have a lot of concurrent namespaces and processing so that not every spend of Rev needs to be sequentialized, but on the other hand, we need to also prevent double spend. So how is the Rev namespace going to be compositional, if that's the correct phrase? Is that easy to describe?
Yeah, I mean, you can think of the Rev namespace as essentially I wouldn't think of it as the Rev namespace. Rev works for every transaction. Right. So if you want a transaction to go through, you ultimately have to have phlogiston, and one way to acquire phlogiston is through Rev. Right. So don't think of it as the Rev namespace. That's a different. I wouldn't think of it that way. Right. Rev is just simply one means by which you can get to phlogiston. And then the roll-up has to do with the fact that every transaction is always of the same form, and then you're just simply detecting whether or not whether transactions conflict or not. Right? Does that make sense?
So far, but we've also made the statement that not every node needs to run every namespace.
That's correct.
But are there some nodes that ultimately need to run every namespace that could potentially spend the same Rev?
If there are for every transaction in the system, that transaction has to roll up to the namespace that encompasses all of the resources mentioned in that transaction. So think of it as like kind of delayed or lazy, right? We don't know what namespace we have to work out until we see the transaction, and at that point we know the entire namespace that's mentioned in that transaction because we have all the locations associated with that transaction. In other words, you can calculate just by looking at all of the locations mentioned in the transaction. So think of every location as effectively it's a logical URL. It's the URI. Right. And now that URI, every single one of those URIs, in order to be messed with, you have to have some Rev that's associated with messing with that URI.
Yeah, got it. So say there were two transactions at the same time from the same address, if you will.
Same URI.
Alice spends to Bob, and Alice spends to Carol.
Right. So both of those transactions mention the same URI.
Alice, yeah. Okay, so all right, so they need to be cleared by the validated and so forth by the
Validated by a validator that sees that is watching that URI.
Okay, got it.
Validated by, in fact, by a collection of validators that are watching that URI.
Okay, got it.
Yeah.
All right, that helps. Part of this is sort of my undoing of thinking and knowing about Bitcoin, which is the UTXO model, which of course is not what we're intending.
Right. Right. Understood.
Okay.
Absolutely. No, that's a good. These are all great questions. I really appreciate it.
So no, it's just as part of my confusion that needs to. And so yeah, I'm closer. I'll have more questions later. Sorry for that diversion.
Keep them coming. Keep them coming.
All right. So with the dev team yesterday, we had a review of this work breakdown structure spreadsheet that we've pointed the community at earlier. It was a good walkthrough. We had, in addition to the document itself, we also had some meta conversations, and those were just as interesting about methodology that we're going to be using, as well as, is it really worth bringing the whole dev team through every line item when we don't really care? A particular dev might not care about the whole architecture. And what I found interesting is, the team wanted to continue doing that, but by and large, and I certainly saw the benefit, because something that's written down, you think you understand it, but when you start talking about it, you change your interpretation. So even though I was the original author of that work breakdown structure, as we went through it, my understanding of a couple of those items changed as we talked through them. So that was very helpful for me. We essentially declared victory on the M1 milestone, which was the first column there. We had a couple of items that are unfinished in terms of updating the Rolang spec was an action item that came out of that, as well as getting an outline for the Casper protocol. And that's more future, but those are things that would be very helpful to do. And again, just to echo what Greg said earlier, if we can get the community involved in some of these updates, that would be awesome.
Yeah, absolutely. One of the reasons that we have a little bit of the backlog on the Rolang spec is we want to make sure that all of the added features have a crisp equational semantics, right? And right now, for example, and that's one of the things I wanted to do in the technical part of our Hangout was to go through one of those in just a little bit more detail, so people can kind of get a flavor and learn how we think about Rolang and smart contracts and the computational model. And to set the stage for this discussion, I wanted to respond to a question that came up in Slack. I think it was Jacob Basiri who had said, hey, it looks like Casper is the magic here. Can you talk a little bit more about Casper? And I didn't have a chance to respond because I've been working really hard on a lot of things. But I feel like in order for this to work, there's, yes, the replicated consensus component is awesome. It's a really, really important piece. But what I was trying to say before when I talked about how that will be commoditized, right? That's completely algorithmic. You can replicate regular expressions. you can use a Casper-like algorithm to have a decentralized world computer that calculates regular expressions. And it might have some utility. It might be an interesting service, but it's not going to be the service on which you replace the world financial infrastructure. And so what that said, hopefully what that says is that the computational model that is replicated is at least as interesting as the distributed consensus algorithm, right? So the magic is actually in lots of different places. It's all around us, so to speak. But in particular, the Rolang computational model really requires a mind shift. And it keeps happening, right? I mean, Ed's question about namespacing was a really good example, and all of us, including myself, keep coming to these aha moments where we realize, oh, this is one of these implications of this other computational model. So that's why it's really important. I also, I just remembered, speaking of this other computational model, that I need to do an update also on the work that we're doing with K framework. But we'll save that for the end. So with that kind of a preamble, if Mike and Joe want to step forward a little bit, maybe we can talk, just have a little discussion here about what it is that we're doing and why it's important with respect to the language features, and most importantly how we're going about doing that. Who wants to give a kind of a summary of our current discussion? Mike, are you up for it?
Yeah, sure.
Cool.
Let me screen share just a sec. Great. So we've been working on desugaring. So the idea is that the base calculus that everything, the kind of machine code level stuff in Rolang is augmented with what we call syntactic sugar that makes certain constructions easier for the programmer to write. And Greg outlined some test cases for what he would like the semantics around collections to mean. Now, here's a collection call, and this says, if we read out an element from a collection and then print some function of that element, that should be the same as mapping F over the collection and then reading an element out of that new collection and printing it, which should be the same as reading a collection from some source channel and then reading the elements out of that collection and printing it, where we send on the source channel mapping this function over the collection. And so then here are some proposed desugarings of mine. Greg has his own desugarings up above that he's written up since I last talked to him. My idea is based on the notion that we have something that I'm calling a unary object template. A template is something that takes in names and produces a process. And an object in a process calculus is a process that listens on a name for method calls and return channels and does something with the data passed along that. So in this case, I'm proposing that if you send a template on a channel, what that really means is that you instantiate the template with a new name n, and then you say to that object, hey, instantiate your iterator on this new name m and send all of your contents on m. And then what you actually send is this new name m. If you want to access the methods of the object directly, then you use this slightly longer syntax. Similarly, if you use a template that's a collection on the right-hand side of an iterator, that desugars to this thing, which is basically doing the same thing. You instantiate the object, you tell it to iterate, and then you read from the channel on which it's iterating. Then if you have the yield keyword in there, that's parametric in two templates, one named T and one named F, and the whole thing evaluates to a template that says, if you give me a name, I will create the T thing, and then I'll listen for messages, and when I get iteration, I'll make T iterate, and then do F to the things that I get off of it and forward them to this new name N. I'm sorry, forward them to the return channel that's sent on the method call. And then I do a whole bunch of computation to show that all of the equations that Greg wanted actually work. So this is the kind of work we've been doing with Greg and Joe and myself over the past week for 4 or 5 hours.
Yeah, thank you. That was fantastically lucid. I mean, there are a few things that I'd like, high level points that I'd like to call out. One is that I really liked Mike's idea that in general, contracts should be able to go into the right-hand side of the for comprehension arrow. So, Mike, would you highlight?
Sure, right there.
Yeah. So in general, contracts of a certain shape should be able to go there, and that makes it consistent with our behavioral typing story. So that's one of the things I really, really like about Mike's proposal and the direction of Mike's thinking. One of the pieces,
as well as being able to send contracts on the right.
Yeah, exactly. So in other words, there's a sort of desideratum for first classness of contracts as collections, collections as contracts, which is very much in alignment with the sentiments of the church numerals paper and a bunch of other things that have the church numerals Rolang style paper that I produced in January, and which was inspired by Milner's work in the pi calculus tutorial on representing data structures. So I really like that direction. And what we've been doing is placing that desideratum, which is highly laudable, up against another desideratum, which is represented by these test cases, right? Which is effectively a kind of referential transparency. What I intuit a programmer's intuitions to be is that when she sees something like for elem from collection print line f of elem, what she's expecting is that it prints f of elem in one line after the other. So if the collection were the list 1, 2, 3 and f were x squared, then what we would see is 1 on the first line, 4 on the second line, and 9 on the third line, and then it would stop. And that ought to be the case whether or not the collection were inlined, right? We just put a list 1, 2, 3, right, where Mike has highlighted blue, or the collection were calculated, as we do, as we have in the second line, and exactly there. And that should be the same as if we calculated the collection and then sent it over a channel, right? In each case, the programmer's intuitions, in my opinion, would expect that if we can, so there's this notion of weak by similarity. So if we can kind of forget about the communication across the source channel for a moment, that all three of these should result in more or less the same computation. And so what we're doing when we do these calculations is to formally prove in an equational style that in fact all three do produce the same computation. So this is the kind of development methodology that is made possible by having the kind of semantics that we have. And this approach goes all the way back to the pioneering work that Robin Milner did with ML. So with the semantics of ML, and I heartily recommend anybody who wants to see the inspirations that are driving this project and many others around the world, go look at the Milner's original specification for ML. It's done in exactly this style, and what's amazing about it is how slender it is. It's a tiny little book, and yet ML has had a major, major impact on the programming languages of the world. From ML, we not only get standard ML, which many programs are written in, but we also get OCaml. OCaml is a direct descendant of ML. And F# and Scala are both direct descendants of OCaml. So Milner's work gave rise to a very large swath of production grade programs out in the world. And that's precisely because of the simplicity, lucidity, clarity of this approach to language design and thinking about computation. And in this particular case, it's really, really important because on the one hand, we're dealing with the internet, where we need to be able to prove end-to-end correctness about systems that are built out of distributed communicating processes. And at the same time, we need to be able to do that in a way that's tractable. Again, the evidence keeps coming in that this is not only tractable, it's actually quite fun. So I'm hoping that the work that we're doing here can go into a communication with the community so that they can get a sense or a feel for how we're doing things with respect to Rolang, which then helps them understand Rolang itself and how to program in Rolang.
And one thing that Greg didn't mention is that these desugarings will be built in directly to the compiler in the first version, but later we intend to provide the ability to write your own desugaring patterns as a first-class piece of the compiler, and then these will merely be instances in that system.
Yeah, exactly. So the one of the key features of the row calculus model is that it has the basics of hygienic macro capabilities built in. It's just a part of the computational model, and from that you can build a sort of roll your own desugaring mechanism, and so we fully intend to provide that. But initially we want to craft it carefully and then kind of release it out into the wild for people to do whatever they want with. The other piece of the puzzle there is that this is a unique setting in the sense that for the first time in a concurrency setting, the first class macro mechanism is integrated with the type system. So we have for the first time in history a computational model that integrates meta level programming or reflective programming, concurrency, and typing. They're all part of one system. And that's very. It's not only unique, but as I pointed out in the Ethereum meetup in January, I think it was, of this past year, if you do an analysis of the blockchain space, all of the computational elements that you find in the row calculus are called for by the domain, and so that's what we're getting is this nice match between domain requirements and computational model, which makes it much more compelling. And that's loops back to the point I was making all the way back at the beginning when Jem was asking about the parity bug, which is that it really, really makes a difference what model you replicate, what model you add consensus to. And this also harkens back to Jacob's question. If your model fits the domain, which is like in this case the blockchain market requirements, then you have a much greater chance that you're going to be able to scale up in the way that's necessary, because you're not constantly trying to do pipe fitting between the computational model and the requirements set out by the marketplace. Okay, that was a mouthful. Hopefully, it made sense. So there are a couple of other points we want to touch on. One is that Mike and I have been driving out the ladle implementation in terms of K framework. So Mike did some nice work on providing K framework specs for the different combinator calculi that we wrote papers about back in the late spring. Mike, you want to just give a quick screen share of the one of the combinator specs?
Sure. Let's see. Yeah, here's one.
Cool. So this one is.
Would you prefer the Yoshida one?
It doesn't matter. I mean, either one. I mean, basically, I'm not sure that people. Yeah, sure, we can use this one. So here we have you can begin to see the kind of specification that we're hoping to be able to provide much more generally. So you've got a place in the module where you specify the syntax of the language. So in this case, it literally maps onto the combinators of the Yoshida style, our reflective version of the Yoshida style calculus. So you've got
just to touch, you've got distributive combinator, a constant combinator, a forwarding, branch right, branch left, and S is it does this.
Synchronizer.
Synchronizer, sure, yeah. And then there's an output, which is a message. This is the star operator that's dereferencing, same as in Rolang. Here is the quoting. I've got an ID in here just to make certain things convenient, but it wouldn't be in the actual implementation. So here's the syntax as to what our program structure looks like. And then down here, we see rewrite rules and the configuration, what the state of the computer looks like. In particular, there's a bunch of things that are waiting for messages as well as the messages being sent. This starts out with a collection of terms, but these two rules peel off the ins and outs. And so at the end, you're left with an empty set of terms. And then these rules here tell how to interpret each of the combinators.
And these rules are taken directly from the paper.
Yes.
So the correspondence between the actual executable spec and the math is 1 for 1. So that's one of the reasons why it's important, and that's important because we need to have an audit trail that goes from the math to the automated calculations of the math, so that there's no gaps anywhere. It's one thing to say, oh yeah, I have this cool algorithm, and here's an encoding of the algorithm in Hall or Isabelle. Oh, and here's some C code, and the relationship between the paper and the Isabelle encoding and the C code. Well, got to trust me on that. Here, what we don't want that. What we want is to minimize the amount of trust that has to be applied, so that there's a one-for-one correspondence between each of these elements. So then the next step in these specs is to add the collection type syntax and rules. And that gives us the combined theory, which is essentially the syntax of the type system, and that's what we're working on. This, by the way, I should also step back a little bit. This has also been a bit of a feasibility study, So we've been checking, essentially checking to see whether a K framework can really handle all our requirements. And there are definitely some places where we're pushing the envelope for K. They've been very responsive to our questions, but we're definitely pushing the envelope for K framework. So we've been learning exactly where we're pushing the envelope and where we're at least I'm being boneheaded about how to encode this stuff in K framework. And then once we have the input for the collections, then we can interpret the distributive law also as a series of rewrite rules. That's possible. Now the question whether we want that to be given the same execution semantics as K framework would give it, that's still an open question for us. And then there's this nice idea that we've been pursuing that has to do with treating the type checking entirely in terms of subtyping. And that we're still sort of working out whether or not that's feasible. But if that turns out to be feasible, then the beauty of that is that it gives a very, very clear and strong interpretation that the logic derives entirely from the distributive law. So the whole name ladle, logic is the distributive law, is very, very justified by that presentation. So maybe that's a lot to take in at the end there. But in the big picture, to make Ed happy, what this leads up to is an implementation of the type checker for Rolang, for example, and even a typed version of the Rho VM that's done entirely in terms of the proof theory side, which should be considerably faster than the model checking approach that we had originally planned. So that's how this work fits in. And again, to loop back to Jim's questions all the way back at the beginning, the reason this is important is because this is the mechanism by which the type system prevents things like the DAO bug from even compiling. And if my reading of the parity bug is correct, it's also how we would prevent code like the parity bug from ever being deployed, because it just simply wouldn't type check and therefore wouldn't compile. So that's why this work is so critical to the whole juncture. All right, that's kind of it for these updates. Any questions, comments, concerns?
One comment about Ed's query on double spends and maybe thinking about it more like the namespace being composed of the common scope of things. And if something is out of scope, it's not in the same namespace. I don't know if that helps at all, but I'm thinking, that also relates to, going beyond Casper, in that we end up with the largest islands of consistency associated with the namespace as being a winner of the consensus games. I don't know if that's correct.
Yeah, I mean, they're absolutely related in that way. So yeah, that's a good observation. Cool. Any other questions, comments, thoughts? Lively group today.
Good hangout.
Good hangout all. See you next week, and see a lot of you at Dev Stand Up in just a few hours.
That was awesome, Greg. Thank you.
Thank you. Ciao.